Okay, so my topic is about trying to find which lipid nanoparticles are able to effectively treat glioblastoma brain tumors. My name is Saimanasaa. So about me, I am a senior at Emerson High School in McKinney, Texas, and my aspiring major is neuroscience, but with this topic, that kind of incorporates oncology as well, so it will give me a better understanding about the brain, its structure, and its functions. So first, glioblastoma brain tumors, right? They're actually a very severe brain tumor. In a scale of 1 to 4 is 4, a very severity, and the average survival rate, even after treatment, is only 5 to 10%. So it is very dangerous, as well as very uncommon as well. It can start in either the brain or the spinal cord. So the formation of it starts in astrocytes. So astrocytes help to protect the neurons against any unneeded or toxic-related compounds, as well as form synapse connections contributing to a healthy nervous system. However, if the glioblastoma actually starts in astrocytes, right, then it can actually break its functions to no longer be effective. It can definitely go on to damage healthy cells and just spread out throughout. So the importance of it is that it starts in the brain, and the brain is probably one of the most important organs in our body. So many different functions, and we can't really live without it. And the problem with glioblastoma is that there's no exact cause or solution. However, we can definitely go on to take effective methods to at least try to help minimize the problem. So let's first talk about current medications, chemotherapy. So chemotherapy is used a lot, not only in glioblastoma, but also in just many different cancers in general. And the problem with that is that its inability to differentiate between which one's a cancer cell and which one is a healthy cell. So that leads to a lot of problems. So although it's kind of minimizing the cancer cells from happening, it's also deleting the healthy cells which are actually good for you. And the effects of that is that you can lose hair, weight changes, fertility barriers, and constipation. And the reason why people lose hair is because the healthy cells are getting removed from the body. And although the chemotherapy is not a very longest treatment out there, they have a very long-term side effects for patients, and they can definitely be in a lot of suffering with this treatment. So why lipid nanoparticles? Right? Lipid nanoparticles have that targeted treatment unlike chemotherapy. They're able to effectively differentiate which one is a cancer cell and which one is a healthy cell. So they're able to only just target the cancer cell. Also, they're able to effectively go past the blood-brain barrier, which is an important barrier inside the brain. So this is a barrier that, in order for medications to get crossed through, they have to cross this barrier. However, it's very hard to get through because it's very small. And chemotherapy has a very hard time getting through that. But because nanoparticles in their unique size are very small and surface modification and have biosafety, they're able to effectively get past through that. And also, there's not a lot of really harsh side effects for patients. That's why I picked this for my topic. Considering methodology, essentially, I just try to see which lipid nanoparticles are able to effectively treat the glioblastoma brain tumor. And I compiled a lot of academic journals and primary sources, such as different peer-reviewed journals, clinical data, and academic literature. And the good thing is, because they're gathered very globally around the world, it's able to gain a lot of different insights about how, even though many people are using it from around the world, it's the same type of idea, and why lipid nanoparticles are really beneficial throughout. So from a results and conclusion, there's still going to be some more further research on this, but I discovered that liposomes and solid lipid nanoparticles are very effective for crossing the blood-brain barrier and actually treating glioblastoma brain tumors. For example, for liposomes, they have a really diverse range of therapeutic drugs and nucleic acids and proteins, so that makes them very adaptable in different situations to be able to input them. And also, the efficient drug delivery as well to be able to cross the blood-brain barrier is very effective. And for solid lipid nanoparticles, they're very biocompatible and biodegradable, so it means that they're very safe to use. So even at a high production, you can use them very safely at a lower cost as well. And they also have efficient drug delivery and able to cross the blood-brain barrier, which is very important. And for the conclusion, I think it's very important that lipid nanoparticles, like using them in the healthcare industry, is important because a lot of patients are really having a hard time with chemotherapy because even though it might work to an extent, there's a lot of long-term side effects, like I mentioned, and with this targeted therapy of lipid nanoparticles, we're able to use it more efficiently and actually help at least minimize glioblastoma brain tumors, if not completely, because of course there's no actually real solution to it, but it can definitely be an efficient use to limiting it. And that's my presentation.
Excellent. Thank you so much for doing that. And also, can you share your thoughts about the Gifted Gapper program?
Yeah, I think it was a really good experience for me. It really challenged me a lot. And I'm really thankful to Dr. Christina for helping me throughout my uh, research paper. I know we were actually working on it yesterday to kind of correct like the different sentences and everything like that. And also, I'm really thankful for all her help, to just taking her time out of her day to help me with it. And I'm also thankful for Dr. Virgil for helping me with my paper, just the formats and everything, and just making it more concise in general. So I'm looking forward to publish it soon.
Excellent. Excellent. And we also are working towards a phase two, or converting it into, we need a passion project. Colleges are looking for passion project, activism and everything. And we want to promote your research into a passion project. So please reach out to us and we will help you further with that. Okay. And a question from Dr. Christina.
Yeah, it's a very interesting topic. I learned about a new type of tumor. I didn't know. So my question is, in your own opinion, what is the most important crucial advantage of nanoparticles, particularly lipid nanoparticles, in comparison with the traditional treatment?
Yeah, so lipid nanoparticles, I think the main thing why I chose it was because they were able to effectively cross the blood-brain barrier. That's very important because a lot of treatments, like I said, like chemotherapy, because they're kind of not as small as lipids, they're not able to effectively cross it. Even though it might have the medications, it can't actually get to the brain itself. So I think that's why I chose lipids.
Yeah.
Okay, great. Wonderful. Thank you so much.